Okay. Hi, welcome to today's reinforcement video about the four angle properties. So here I've actually drawn out for you a circle with a center. I'm going to show you, demonstrate to you how the angle property one always holds good. So the first property states that angle at the center is always two times the angle at the circumference. So let me show you how this works. Let me choose a point, 2 points here, A and B, and then let me start to draw out. Let me choose a point here, A, okay, and then let me draw the angle from here. Okay, now I'm going to choose a nice angle here so that you can actually be clear when I demonstrate to you, but actually any angle will work. Okay, so somewhere around here will be say 80 degrees. So let me choose a point around there. But oh, never mind, let me actually leave it to let me just try it out. I think should work fine. Okay, this point here, B. So I have drawn AOB. Let's measure angle AOB. So I have measured this angle. It is about 88 degrees. Now from the same 2 points A and B, I'm actually going to draw lines to the circumference of the circle. I can choose any point on the circumference. I can choose here, I can choose here, wherever. If I actually draw from the same 2 points A and B, let me draw. Okay. Now if I measure this angle here, APB, you observe, of course, that APB is smaller than this. Okay, so if I measure this, what I expect to see is that I should get exactly half of this point here. So let's start to measure this angle here. Let me show you. Okay, so if I measure angle APB, what I get is I get exactly 44 degrees. Okay, if I zoom in, you can observe I will get exactly 44 degrees here. Okay, that goes to show that angle at the center is always 2 times the angle at the circumference. So if this is x, this will always be 2x. Okay, so now if I have an angle here, if I draw something here on this side, if I face the opposite direction, if I draw here, you'll observe that this angle will be 2 times of the reflex angle here. Okay, so this is the first property. Angle property 1 is angle at the center is always 2 times the angle at the circumference. Okay, so let's move on to the second property. The second property states angle in a semicircle is 90 degrees. So let's draw a semicircle. For that we need a diameter. So a line that is passing through the center of a circle. I can draw the diameter like this, or I can draw it like this. However I draw, okay, it doesn't matter. So I'm just going to choose to draw it like this as long as it passes through the center. It's fine. So I've drawn a line passing through the center, and I'm going to draw any angle here, any triangle here. Let me choose a point here and then try to draw the triangle here from the diameter. Okay, so let's measure this angle here. Okay, if I measure this angle here, I should be able to see that this angle is exactly 90 degrees. Yep. Can you see? It's exactly 90 degrees. Now, it doesn't matter if I draw another triangle here. If I start from the same points A and B, and then I'm drawing another triangle here, choose any other point on the circle. If I choose this point here, all the way to A, okay, and then if I draw it from here to B, I'm drawing another triangle here with the AB as a diameter. You will observe again, if I measure this angle here, it will still be 90 degrees. Can you see? It's still 90 degrees. So any angle that is formed, okay, the angle subtended by the diameter, then you have the diameter. Diameter will always be the hypotenuse, okay, in this right angle triangle. It will hold good even if I draw on the other side as well. So angle drawn angle in a semicircle, if I cut the circle into two equal halves with a diameter, if I draw triangles, okay, the angle that is opposite to the diameter will always be 90 degrees. So we can state this property as angle in a semicircle is always 90 degrees. Let's move on to the third property, angle in the same segment, angles in the same segment. So I'm going to choose any 2 points here, any 2 points on the circle. I can choose it here, maybe A, and then I can choose it here, B, wherever, okay, it doesn't matter. I'm going to draw angle from, I'm going to draw a triangle from A to B, starting from A and B to this point here in the circle, okay. Now I'm going to measure this angle here. If I measure this angle, I get about 52 degrees. Okay, 52 degrees. Now, I am actually from the same point AB, I'm going to draw another triangle. It can be wherever. I'm choosing a random point here. And then I'm going to draw two lines all the way to the circumference, making an angle. If I measure, now you can see that there is a bow, the bow tie kind of structure here, right? So if I measure this angle here, okay, if I measure this angle here, I expect it to be exactly the same, which is about 52 degrees as well. Okay, no matter how many of these that I draw, I can keep extending. However I draw it, I can choose a point here and then still draw. I can draw from A to this point and then from B to this point again. You will still observe that this angle property holds good. Okay, this angle will further, if I measure it, you can observe that this angle will also be 52 degrees. Okay, I can measure this angle and show you this angle is also 52 degrees. Okay, so this is what we mean by angle in the same segment. Okay, if you have starting from A to B, if I draw here, this angle will be the same as starting from A to B if I draw to Q, starting from A to B if I draw to R. All of these angles are the same. So this is called angles in the same segment. Now, if you have a bow tie, the other way to look at it is, I can show you, if I have a bow tie like this, you can also easily identify this kind of a shape. Okay, you observe that these two angles will be the same. And if I look at it from the other side, these two angles will also be the same. Okay, so to say that this angle here will also be the same as this angle here. Okay, in this bow tie. All right, or you can also look at it as starting points, angles in the same segment. Okay, now the fourth property, which is the last property, is angles in the opposite segment. For this, we need to draw a cyclic quadrilateral. Cyclic quadrilateral means that we are having a quadrilateral, a four-sided figure inside the circle. So I'm going to choose any 4 points and I'm going to draw a cyclic quadrilateral. Can work for any 4 points. Okay, just choosing random points here to go and draw a cyclic quadrilateral. Okay, now if I measure the opposite angles of this cyclic quadrilateral A, B, C, D, if I measure this angle and this angle, let's do that. Let's see what the angles add up to. So this one is about 77. Now let me measure this angle here. This one here, this angle is about 103. So you can observe that both of this 77 plus 103 will add up to give you 180. So you notice that when I have the opposite angles, okay, it will also hold good for this one and this one here. If I measure these two will also add up to give you 180. So this is the property where you have the opposite angles of a cyclic quadrilateral adding up to give you 180 degrees. So this property is also called as angles in the opposite segment. So it's like from AC, I'm going this side, and from AC, I'm going this way. So the opposite angles, right? Opposite angles in the opposite segment are equal. So this is the property, opposite angles of a cyclic quadrilateral add up to 180 degrees. Okay, so these are the 4 properties. I hope they are quite clear now. You need to apply them when you do questions. So go through this. Hopefully you'll be a bit more clear. Thank you.